Okay, so we're going to consider with some more examples here of some derivatives. These may be a little messier than what we've been looking at. Consider our next example here. So we have g of w equals 8 over w cubed plus 9 times the cube root of w. Okay. So we want to find the derivative of this thing. We want to find g prime. So before we can find g prime, we do need to do a little bit of rewriting with this stuff. So to do the power rule, you have to have everything up on the top, so that over w to the third we need to rewrite as 8w to the minus third. Right now that's in the right format to do its derivative. And that cube root I have to write as a fractional exponent. So plus 9w to the 1/3 power. Okay, so now I have done the work that I need to do to take the derivative. So now we go ahead and we do just that. G prime, respect to the variable. So for the first one there, I would multiply by the exponent, the minus 3 times the 8, and then drop it by 1. That would actually turn into a minus 4 now. Continuing, 9 stays output. W to the 1/3, we would multiply by the exponent, the 1/3, and then drop it by 1. 1/3 minus 1 will be a negative 2/3. 1/3 minus 1 will give us a negative 2/3. All right, and then we go through and simplify here. 8 times negative 3 will be negative 24. That'll be my number. That'll go on top. And then w to the minus fourth will go to the bottom as w to the fourth. We continue. 9 and 1/3 would each be 3. And that negative exponent stuff will need to go to the bottom. And when it does, you'll have w to the 2/3 power down in the bottom there. W to the 2/3. So the final answer is negative 24 over w to the fourth plus 3 over w to the 2/3. Okay, so let's move on to do one more example here. Again, this is another derivative that's a little messier, not as neat as some of the earlier ones. So this time we're once again using this derivative operator notation. So we're taking the derivative of the stuff inside the brackets. Here we have 1.8 over the square root of x minus 4.6 x to the negative second plus x. Okay. Of course, to do the derivative of this first part, I'm going to need to write that so that I don't, so it's x to a power. So a couple things being in the bottom, that square root would be x to the 1/2, but since it's in the bottom, when it pops up top, so that it's in the format that we can do the derivative of it, that'll be x to the negative 1/2 power. And then we have minus 4.6 x to the negative second and plus x. And then we just go through and use our derivative process. So that means we're going to multiply by that power. So it's going to be 1.8 times a negative 1/2. And then we drop that exponent by 1. So negative 1/2 minus 1 will be x to the negative 3/2 minus 4.6. Multiply by the exponent, negative 2. Drop it by 1 would make it negative 3. And the derivative of x would just be plus 1. Right, and then we just keep going. A little bit of cleaning here. This is going to be negative 1/2 times 1.8. Be negative 0.9. And then I'm going to take that x to the negative 3/2. I'm going to slide that down into the denominator because it has a negative exponent. X to the negative 3/2. And then I'm going to have a negative 4.6 times a negative 2 is going to become a plus 9.2. And then I have an x to the negative 3rd. So that's going to slide to the bottom, becoming just x to the 3rd. And then I have just plus 1. And so now I have worked out the derivative of this rather complicated mess, and I end up with, one mistake I made there. That should not be a negative 3/2. Now that I've moved it, it would just x to the 3/2. There's still a negative 0.9 though on top there. Oops. It's still a negative 0.9 up there though. Okay. So now we've worked out that derivative.